Let's suppose we've got a couple of lines. Line 1 is the line that is parallel to the vector 2, negative 1, 3, and passes through the point negative 9, 7, negative 12. And line 2 is parallel to the vector negative 3, 2, 1, and passes through the point 13, negative 6, negative 1. So we've got these two lines in space, and we want to determine if they intersect, and if they do, what is that point of intersection? Well, first of all, let's write our parametric form for both lines. So for this first line, line 1, I have x equals 2t minus 9. That's the x coordinate. And we've got the y coordinate would be negative t, right, from that vector, plus 7. And then z is equal to 3t minus 12. Okay, so I just use this vector and that point. Now, for line 2, I've got x equals negative 3. And let's not use t again. Let's use a different parameter. Let's use s, plus 13. And y equals 2s minus 6. And then finally, z is equal to s minus 1. There. So we've got our two equations, L1 and L2. These are two different lines, and we want to determine if they intersect. In other words, is there any point that they share? So here's what we need to do. The way we can proceed with this, we use the x and the y's first. We don't have to. We could use the y's and the z's, but we want to use two of the coordinates to determine if line 1 and line 2 share any common x's and y's. So in other words, here's what I'm going to do. I'm going to take, on the one hand, x 2t minus 9. That's this right here. And I'm going to set it equal to, and by the way, this is equals up here. Notice I put a negative. There should be a negative here, though. So this is equal to negative 3s plus 13. Okay, so what I'm saying here is I'm going to see if there's a t and an s that will make this x from line 1 equal to this x from line 2. Well, I've got two parameters here, right? A t and an s. I need another equation with a t and an s so I can have a system of two variables and two equations. So let's go to the y's. I've got y is equal to negative t plus 7, and I want to find out where that's equal to 2s minus 6. So now we are set up to find a t and an s that will give us for both lines, the same x values and the same y values. So we'll have two of the three coordinates matching up once we solve for t and s. So what I'll do is I will put this in the form that we're used to. 2t plus 3s equals 21. I guess 22 now. 13 and 9 is 22. And then I've got negative t minus 2s equals negative 13. Okay, so here's what I want to do now. I want to solve the system of equations. And the method I'll use to solve it is elimination. Let me call this equation 1 and this equation 2. Now what I want to do is eliminate one of the variables. In particular, I'll eliminate this t. So I'll multiply equation 2 by 2. So I get negative 2t minus 4s minus 26, and then I won't do anything to equation 1. I don't need to because now I'm set up to eliminate the t's. So I add these, I'm going to get the t's are gone. I've got negative s equals negative 4, or s equals 4. Now I got to find t, and I can do that just by plugging in any place s and t are together. So I'll just go here. I got negative t minus 2 times 4 equals negative 13, or negative t equals negative 13 plus 8, that's negative 5. t equals 5. There. So now I have s is 4 and t is 5, and what I found the value of the parameters that make sure that the x's for both lines are the same and the y's for both lines are the same. In other words, I'm working on finding a point of intersection, and I found that I can match up the x's and the y's. In other words, I found the x and the y coordinate for that ordered triple where these lines intersect. So let's check that out. So I've got x equals 2t minus 9. Okay, so here I go. X equals 2t minus 9. And also x equals negative 3s plus 13. So let's see what that is. Well, that's 1 for that first one, and then 1 for the second. So on this ordered pair, the point of intersection, I've got 1 for the x. Now let's see what the y is. The y coordinate is. We've got y equals negative t plus 7. So that's negative 5 plus 7. And for the other line, it is 2 times 4 minus 6. Okay, so that's going to be 2, and over here 2 as well. So the y coordinate is 2. Now, we don't know for sure that, going through this process, I don't know for sure that the z's are going to match up. They've got to match up, though, if this is indeed a point of intersection. In other words, if there's a point of intersection, when I put in the 5 for t and the 4 for s, I should get the same z. And whatever that z is, it's going to be the third coordinate, and then we'll have our point of intersection. So here we go. Let's see what we've got here. We've got z is equal to 3 times 5 minus 12. And also we've got z is equal to 4 minus 1. Well, so this is 15 minus 12, that's 3. 4 minus 1 is 3. Oh, look at that, 3. They match up. So with these parameters, t is 5 and s is 4, we come up with the point of intersection to be 1, 2, and 3. So the point 1, 2, 3 is on line 1, and it's also on line 2. Therefore, that is our point of intersection. Now, to see what that intersection looks like, I went ahead and graphed it in GeoGebra. And you notice here are my 2 lines. There's the one and there's the other, and there's the point of intersection. That is 1, 2, 3. The thing about these lines in 3 dimensions, they're not guaranteed to intersect even if they're not parallel. If we've got 2 lines on a plane that are not parallel, then they are going to intersect. But that's not the case with lines in space. It requires a little more investigation to determine if they intersect. And if they do intersect, to find the point of intersection requires a little more work. But there's a picture of what we did.